Today we're going to talk about our definitions some more. What we find is when polynomials are written, they're the same no matter what order you write them in, but generally you write all the degrees going down in descending order. So here I have a polynomial. Remember that the adding, so here I have adding, adding, subtracting. The adding, adding, and subtracting separates this into different terms. So that polynomial there has 4 terms. And if we look at the degree of each term, it's written in top in green. The degree of this one is 4. The degree of this one is 2. The degree of this one, even though it's not written, there would be an exponent of 1 there. So we remember that a degree of a polynomial or a degree of a monomial is adding up the exponents in that term. And then the degree of the whole polynomial is just the highest one. And right now, can you see that the degrees are written in descending order? Generally, when you have textbooks, they will try to write polynomials in descending order. The second one is not in descending order because this first term has a degree of 1. This second term has a degree of 2. The third term has a degree of 0 because it has no variables. And the last term has a degree of 3. Beth, do you want to take out your booklet from yesterday? So you could rewrite this one in the proper order. And if, notice how the biggest one is a 3, but there's a subtracting sign in front of it. If you write that first, you have to include that negative sign in front of it. Whatever symbol is in front of the term stays with that term. So it's negative x cubed minus 5x squared plus 3x plus 4 is writing it in the right order. Next definition. A term with no variable is called a constant, or the constant term. So I've bolded them in your notes, but maybe you want to circle them as well. Okay, again, in this first example, 3x minus 5. Ask yourself, could you say what kind of polynomial is that? What I'm trying to do is strengthen those definitions for you so that when you get to your test, you know them. What kind of polynomial is 3x minus 5? It's a binomial. Okay? Luke, you've been eliminated. That means he's not allowed to answer the next question because he got one right. It's a binomial because it has 2 terms. The subtracting separates it in term 1 and term 2. Okay? What do we call the number 3 in front of the x? What do we call the 3 in front of the x? You're eliminated. You're not allowed. A number in front of a variable. No. Can you get what? A coefficient. Charian is eliminated. Okay? What do we call the x? A variable. Duncan's eliminated. In the second example, we've got negative 7b squared plus a plus 9. What type of polynomial is that one? You're eliminated. Okay, if you're eliminated, you can still see if you can figure out the answer before somebody else in the class. But what type of polynomial is that one? How many terms are there? 1, 2, 3. Trinomial. Jacobi is eliminated. Okay. What is the exponent in that trinomial? 2. Oh. Caden is eliminated. How many variables are in that trinomial? And what are they? 2, and what are they? A and B. Perfect. Logan has been eliminated. Yeah. Like terms. This is a very, very important definition in this unit. Two terms who have the exact same variable or variables and the exact same exponents. Their coefficients can be different. And this is the type of algebra I said you have already done before. If I have 2 pencils here and 4 pencils here, how many pencils do I have? 6. We can add them together because they're the same thing. In math, we call things that are the same thing like terms because you can add them together. But if I had 2 pencils if I have 2 pencils and 1 ruler, what do I have? I have 2 pencils and 1 ruler. We can't say these are 3 pencilers, yes, or rulons, or whatever you like. That doesn't make sense. You have to keep them separate because they're not like things. So you can't add them together. So we say that like terms are when you're talking about the same things. So the variable and the exponents are what describe the thing. The number in front, or the coefficient, is just how many you have. So here are some like terms. 5x and negative 3x are like terms because they both are x's. You have 5 of one, negative 3 of the other one. 4y squared and y squared are like terms because they both have y squareds. They both have the same variable with the same exponents. This is super important for what all the math that we do at the beginning of polynomials is based on this idea of what are like terms and what are not. Even if you have more variables. Here we have an a squared b, here we have an a squared b. And I even wrote a b and an a squared. All 3 of those would be the same because all 3 have 1b and a twice. Yes, that is a good movie. Okay? But x squared and x are not like terms because this one doesn't have an exponent even though they have the same variable. It doesn't matter the order, but as long as, like, whoa, that's yellow. Here we go. Here's a trickier one. A squared b and b squared a are they like terms or not? Not. They seem close, right? Because they both have a's and b's, and they both have an exponent of 2. But can you see that in this one, the b has the exponent of 2. In this one, the a has the exponent of 2. So if I wrote this in expanded form, this is a times b. This is b times a. They're not identical. The variables have to be identical in expanded form. So in other words, they have to have the same exponent with the same variable in each one. So you might want to write this example down in your notes to help you understand it even better. Now for the next example, if you have more than one color of pen, pencil, highlighter, you can use that. If you only have one pencil, you're going to need to use shapes. Okay? I'm going to show you how you could do this. I take out my red pen, and I'm going to circle 4x in red and 2x in red because those are like terms. Is there any other ones that have just a single x? No. Now, if you don't have a different color pen, okay, anybody else see any other ones that are the same? 6a squared and 12a squared. Perfect. So if you don't have a different color pen, use a different shape. I'm going to put a triangle around that one and a triangle around that one. If you have a different pen, perfect. If you don't have a different pen, you need to put a different shape around them. Okay. You could also, that's a great idea. So these two are connected. Those two are connected. Connect the rest of them. That's your job. Okay, can I get everybody to focus here? In a little ways, this matching is kind of fun. I think it's not bad. And when you get one that matches, it actually feels pretty good. So one of the things we could do is we could just go in the order. I'm going to use green next and a square. In that one that I put a green square around, there's 1a and 1b. So when I'm looking for a like term, I have to look, do any other ones have 1a and 1b?
Yes.
Yes. Still has 1a, 1b, even though the order is different, these two are connected. My next one. Whew, this one has a lot of variables. It's kind of in between a circle and a rect. Yeah, it's not a very good circle. Okay? It has 1z, 1x, and 2 y's. Y squared, because the exponent has to be the same. Do we have any other ones with 1z, 1x, and 2 y's?
Yes.
Yes, right there. Do you see it? 1x, 1z, 2 y's. Next color. No, I'm going with diarrhea brown. Yep. Ugh. Okay. Could have just said orange. -5 because it's the only other one without any variables. Next color, bright yellow with a bubble. Is there any other ones? Right below just has a single A. Okay. A star, okay. A star with a dotted purple line. Whew. 1z, 1x, 1y.
4 x, y, z.
Yes. And now the hardest one of them all. The thick. I wonder which one it could be. We need 1z, 1y, and 2 x's. Oh ho. Those are like terms. The definition for like terms is super, super important, that you have to have the same variables. And this will form an important part of our math as we go forward. Few more definitions. An expression, just a group of terms together, is called an expression. An expression doesn't have an equal sign. An equation does. So that's the difference. An equation has an equal sign. An expression does not. So if I look at the expression I underlined in green, what is it called? What's the special name for that expression? What's it called? That expression with two terms. Binomial. Charian, eliminated again. You said it first? Also eliminated Sarah. Okay? So we need, okay, if you're finding yourself, when you're trying to find one of these definitions, flipping back in your notes and having to reread them, that means you haven't learned them well enough yet. Simplification. We are going to simplify expressions by adding like terms. Okay? And this is the kind of math when I said, you already know this because you've done it before. If you had a table, and on the table over here you have 3 apples and 2 oranges. And over here you have another apple and another orange. What do you have on the table? 3 apples and 1 here. 4 apples, 2 oranges and 1 orange, 3 oranges. You would say, oh, I have 4 apples and 3 oranges. Because I would add the ones that are alike when I'm describing it to someone. So when we say we're going to simplify an expression, we're going to want to look and see if we have like terms. We've done a bit of substitution already.
So is that just like what we'd be writing it, just doing like 5 squared, writing it?
Well, if you had this, and then I said, if x is equal to 2, what is this equal to? The substitution would be, I replace the x with a 2. This is substitution. And now I can do the math. Order of operations would say I should multiply first. 2 times 2, 4. And then I add 3, and I get 7. That would be substitution. We replace that variable x because we were told a given value for it of 2. So now we have an expression, 3x squared minus y minus 1. And there are 8 questions you have to answer about it. I'm going to give you, this is to test your understanding of the definitions. I'm going to give you a chance to do it first on your own. Okay, here is our check before class ends. The exponent of the first term. Here is our first term underlined in blue. The exponent is 2. How many terms? There's 3 of them. It is a trinomial. Because there's 3 terms. Next up, I'll rewrite it again. We had 3x squared minus y minus 1. Yes, that was what it was. What is the coefficient of the second term? This is a hard one. If it's not written in front, It is a minus 1. Okay. Which is the constant term? That's your one without a variable. We also keep the negative sign with it, so we would say minus 1. What are the variables? X and y. What is the exponent of the second term? It's a 1, right? Because when it's not written there, there would still be a 1. What is the degree of this polynomial? 2. We figure out the degrees of each term separately, 2, 1, and 0. The degree of the polynomial is the biggest one, which is 2. And finally, the last question here. Write a trinomial of degree 5 that has 4 variables. So I could have x squared y cubed, that has 5 in it, plus a and b, now I have 4 variables, plus 7, now I have a constant. That is putting all the definitions together. So you can, this is where we're going to end for today. You can hand in your note packages to Miss V, and tonight, when you go home to see if you understand this stuff, turn to your textbook and try these questions.